Taylor Series Part 2, 3 Important Series. In the last part, we found that a Taylor series can be written in other form: f of c plus f prime of c times x minus c plus f double prime of c over 2 factorial times x minus c squared, and so on. A side note, a Taylor series centered about x equals 0 is also called a Maclaurin series. In this part, we are going to look at 3 very important Maclaurin series. Let's start by finding the Maclaurin series for f of x equals sine of x. That is, we want to write sine of x as an infinite polynomial. And recall that it is all about finding the coefficients. That is, I need to find f of c and f prime of c and f double prime of c, etc., and hopefully we can see a pattern. This is the way I like to set it up. So I have my function, sine of x, and then I just start taking derivatives. I know f prime is cosine, f double prime is negative sine, f triple prime is negative cosine, and I'll do 2 more. And the reason I do 2 more is because I've done this problem many times. And after this, we should see the pattern. So I found the derivatives and the original function, of course, but now I need to find the values at the center. So I need to find f of 0, which is the sine of 0, and f prime of 0, and f double prime of 0, and so forth. And I get the following values. And all I'm going to do is plug these values back into my Taylor series formula. So I get the sine of x is f of 0 plus f prime of 0 times x minus 0 to the first plus f double prime of 0 over 2 factorial times x minus 0 squared plus f triple prime of 0 over 3 factorial times x minus 0 cubed plus the fourth derivative at 0 over 4 factorial times x minus 0 to the fourth, and then the fifth derivative times x minus 0 to the fifth. And now I'm going to clean this up, which gives me the sine of x is 0 plus x plus 0 minus x cubed over 3 factorial plus 0 again, then x to the fifth over 5 factorial. Can you guess what the next term is? That is the next non-zero term. I bet you put minus x to the 7th over 7 factorial. So this is the Maclaurin series for sine of x. Let's write this in our general case. The sum from n equals 0 to infinity. It alternates, negative 1 to the n. And notice it's exactly the same as the arctan of x, except in the denominator, we don't have 2n plus 1, but 2n plus 1 factorial. So now I would like you to find the Maclaurin series for cosine of x. I recommend that you pause the video and try it on your own and come back when you are ready. So when you did the Maclaurin series for cosine of x, did you think that the cosine is the derivative of sine? Or did you do it the long way? Either way, you should get the same answer. So I'm going to do the derivative version, which means I can take the derivative of each of these terms, giving me 1 minus 3x squared over 3 factorial, 1 times 2 times 3, plus 5x to the 4th over 5 factorial, 1 times 2 times 3 times 4 times 5. And this should be enough to see the pattern. So I have 1 minus x squared over 1 times 2 plus x to the 4th over 1 times 2 times 3 times 4. And I definitely see the pattern going on. Notice that you could have taken the derivative on the general case if you wanted to. I will leave that for you to do. But let's write this in sigma notation. I have n equals 0 to infinity. It alternates, so we have the negative 1 to the n. And notice that all of the powers of x are even, which we write as 2n, divided by that same even value factorial. Let's take a look at our final important Maclaurin series, at least for this video. Let's look at e to the x. So this one you have to take derivatives. But believe me, it's pretty easy to do. Because the derivative of e to the x is always e to the x. And a Maclaurin series means we're centered at 0, which means f of 0 is 1, and f prime of 0 is 1, and f double prime of 0 is 1, and so on. So if I want to write my function in terms of the Taylor series, I could write it like this. I'll do the general case first so we can just plug in. And I get e to the x equals f of 0 plus f prime of 0 times x plus f double prime of 0 times x squared over 2 factorial plus f triple prime of 0 times x cubed over 3 factorial which gives us the sigma notation n equals 0 to infinity of x to the n over n factorial. So my recommendation is that you memorize e to the x, cosine of x, and sine of x centered about x equals 0.